Okay, so here we have a simple parallel circuit. We know it's a parallel circuit because we could follow multiple current paths. So as opposed to a series circuit where there's only one path for current, in a parallel circuit there are several paths for current. The current can come down here, down each resistor, and flow back to the source. In this case, we have a simple parallel circuit that has a source of 60 volts DC, and each of the 5 resistors are 5 ohms each. So ultimately, we want to be able to obtain the total resistance, the total voltage, and the total amperage of the circuit. You know, in a parallel circuit, as we discussed previous, that the total resistance will be a formula, but we don't want to use that large formula. We want to stick with, for now, the formula that says if all the resistors are the same value, then the total resistance will be the resistor value, which is, if they're all the same, which is 5 in this case, 5 ohms, over the number of resistors. So this formula, this shortcut, only works when you have all the resistors of the same value. In this case, they are all the same value, and we divide by the number of those resistors. So we get a total resistance of 1 ohm. And that's just for a parallel circuit, not for a series circuit, just for a parallel circuit when all the resistors are the same. Now we could also write the formula for total voltage, and in this case, in a parallel circuit, the voltages remain the same, or the voltage drops remain the same amongst all the resistors in a parallel circuit. So if we took a voltmeter and we used it across this here, it's going to be the same here and here and here, and it'll ultimately be 60 volts from this point to this point in each of the resistors. So we already have this total voltage, which will be 60 volts. Total resistance, we just determined that, which is 1 ohm. And we want to find the total amperage. Well, the total amperage will be the sum of all the amperages combined, and that is expressed in this formula. Amperage across 1, well, plus the amperage across 2, resistor 2, plus the amperage across resistor 3. This is R1, 2, 3, 4, and 5. And the amps will come, the total amperage will be right here. Right there is the total amperage going out of the circuit, and here's the total amperage coming back into the circuit. So we apply Ohm's law when we determine the total amperage. We apply Ohm's law right in here, and that we could determine, of course, with Ohm's formula, E equals IR, and we're looking for I. That means that voltage, 60 volts divided by 1 ohm, will equal 60 amps. That's the total amperage coming back into the circuit, and the total amps leaving the circuit. Okay. So, knowing those terms, we just need to find now, opposite of the series circuit, we can solve for the amperage across R1, the amperage across R2, the amperage across R3, and the amperage across R4 and 5. And here's how we do it. Well, applying Ohm's law now to this singular resistor now, we have a couple of things. If we want to draw Ohm's law again, is E equals IR. What do we have that we could apply Ohm's law to here? We have the resistance, which is 1 ohm, or which is 5 ohms, and we have the voltage across this resistor from here, from this point to this point. It's the same from here to here. It doesn't matter. We have that as 60 volts. We make that division, and we find that 60 divided by 5 is 12 amps. So we know that 12 amps is coming down this resistor right here. 12 amps is coming down. And basically we apply that same principle or the same law to each of these resistors. Well, all the values are the same. So you're going to get 12 amps through each of those resistors. 12 amps, 12 amps, 12 amps, because the resistance is the same. But here's what I want you to see, and that is when 12 amps comes down this resistor, it is taken from 60 amps. So do a subtraction to see how many amps you'll have left over going through this leg of the circuit. So 12 amps is subtracted from 60 amps, and you get 48 amps. 48 amps. And that principle, you do that same function, you do that same task with each of these legs down each of these resistors. In other words, if 12 amps is coming down here, and 12 amps is coming down here, and 12 amps is coming down here, you have left over on this leg of the circuit, you have left over, after you made the subtraction, 48 amps. Well, another 12 amps will be deducted, and you'll get 36 amps left over. And another 12 is deducted here, and you'll get 24 amps left over. And another 12 is deducted down this branch, you'll get 12 left over. It comes around the corner, the amperage, it comes around the corner here, and it starts combining. This is what Kirchhoff's law is. It starts combining again. So 12 amps is coming down, 12 amps is combined with 12 amps here, and you get 24 amps along this leg. That's how you tell if these amperages match. That's how you tell you're doing your calculations properly, because what is coming out of the circuit is going back into the circuit. So 12 amps or 24 amps is here. It's combining with the other 12 amps here coming down, and that is creating or adding to 36 amps. Again, 36 amps is combined with 12 amps coming down here, and you get 48 amps. 48 amps again is combined with these 12 amps here, and you get a total of 60 amps coming back through the circuit. And you could observe that 60 amps left, that was your total amperage, and 60 amps came back.